Hello students, I am Trupti Patel from Arihant College of Arts, Commerce and Science. Students, today we are going to study common ion effect. Now the name itself gives you an idea students that something is common in this. So what is common and what is common ion effect that we are going to study. So first we'll study what is the meaning of common ion effect. The common ion effect states that the ionization of a weak electrolyte is suppressed in presence of a strong electrolyte containing an ion common to the weak electrolyte. Consider a solution of weak acid CH3COOH and its soluble ionic salt CH3COONA. CH3COOH is a weak acid and it dissociates only slightly in the solution, right? So we can see in the reaction CH3COOH double arrow we can see, which acetic acid gives you acetate ions plus H plus ions. So CH3COOH gives you CH3COO minus ions plus H plus ions. This is weak acid. Okay, by applying the law of mass action to this particular equation, we get Ka is equal to acetate ion multiplied with hydrogen ion divided by acetic acid. So we know how to apply the law of mass action to this equation, to this reaction, where Ka is the dissociation constant of acid. Now for the salt, CH3COONA being a strong electrolyte dissociates almost completely in solution. As we can see in the reaction, CH3COONA gives you CH3COO minus ions plus Na plus ion. Both the acid and the salt produces acetate ions in the solution. Students, just write down both the reactions one below the other so that you will understand. The first one we have taken, I'll just show you. See the first one, CH3COOH gives you acetate ions plus H plus ions. Okay, and in this here also you can see CH3COONA gives you CH3COO minus ions plus Na. So acetate ions are there. So CH3COONA dissociates completely. Therefore, it provides high concentrations of acetate ions. This is according to Le Chatelier principle. The addition of acetate, that is CH3COO minus ion from CH3COONA to the solution of CH3COOH shifts the equilibrium of dissociation of CH3COOH to the left side. Thus, the reverse reaction is favored in which acetate ions combines with H plus ion to form unionized acetic acid. Hence, Dissociation of CH3COOH is suppressed due to presence of CH3COONA containing a common acetate ion. Common ion effect and solubility. The presence of common ion also affects the solubility of a sparingly soluble salt. Now let us consider the equation and understand. Consider the solubility equilibrium of AgCl, silver chloride. Students, we can see the reaction that AgCl gives you Ag plus ions plus Cl minus ions. The solubility product of AgCl is given by the equation, as you can see. Ksp is equal to Ag plus ions multiplied with Cl minus ions. Now suppose AgNO3 is added to the saturated solution of AgCl. I'll repeat. Suppose now if we add AgNO3 to AgCl3 solution. AgCl3 solution is a saturated solution. Now in this AgCl solution, we are going to add AgNO3. The salt AgNO3, being a strong electrolyte, dissociates completely in the solution. Now since AgNO3 is strong, so we can see in the reaction how we are going to get ions. AgNO3 gives you Ag plus ions plus NO3 minus ions. So the dissociation of AgCl and AgNO3 produces a common Ag plus ion. So the concentration of Ag plus ions in the solution increases owing to complete dissociation of AgNO3. According to Le Chatelier's principle, the addition of Ag plus ions from AgNO3 to the solution of AgCl shifts the solubility equilibrium from AgCl, that is from right to left. The reverse reaction in which AgCl precipitates out is favored until the solubility equilibrium is re-established. The value of solubility product, that is Ksp, however, remains the same since it is an equilibrium constant. The solubility of sparingly soluble compound decreases with the presence of common ion in the solution. Now we have studied common ion effect, students, with the example. What is the correlation of common ion effect and the solubility? Now we are going to study applications where this common ion effect is used. First, in the purification of common salt. So the addition of common ion to a saturated solution of salt causes the precipitation of salt. When the ionic product exceeds the solubility product, precipitation takes place. So a saturated solution of common salt free from suspended impurities is taken and HCl gases pass through it. So in a saturated solution of impure salt, equilibrium exists as follows. We can see in the reaction NaCl gives you Na plus ions plus Cl minus ions. Now if pure HCl gases pass through the solution, now being a strong electrolyte, it dissociates completely. So we get HCl gives you H plus ions plus Cl minus ions. Now the Cl ion is common ion. So the concentration of Cl ion, that is the common ion, is increased. So according to Le-Chatelier's principle, equilibrium shifts towards the left. So the dissociation of NaCl is suppressed and pure NaCl is precipitated as solid salt. Thus, pure NaCl can be precipitated by passing HCl gas in the saturated solution of impure NaCl. Isn't it interesting, students? Second, salting out of soap. The addition of common ion to a saturated solution of salt causes the precipitation of salt. So this is also quite interesting application where we use our common ion effect. When the ionic product exits the solubility product, a precipitation takes place. So when the precipitation takes place, this was applied same for the salt also and for this application also. The soap is sodium salt of higher fatty acids, that is RCOONA. So it is prepared by hydrolysis of oils with NaOH. So in a saturated soap solution, there exists an equilibrium. So RCOONA gives you RCOO negative plus Na plus ion. Students, there should be RCOONA, right? So that C is missing over there. So RCOONA gives you RCOO minus ions plus Na plus ions. Now if a small amount of NaCl is added to the saturated soap solution, so we get NaCl gets dissociated into Na plus Cl minus ions. Now the concentration of Na ions, that is a common ion, increases. Students, when you write both the reaction one below the other, you will understand there is a common ion. So in this, Na ion, that is common ion, increases. Due to common ion effect, dissociation of soap is decreased and soap gets precipitated and then can be easily removed from the soap solution. So this process of getting soap from soap solution by adding salt like NaCl is called salting out of soap. Isn't it interesting, students? Thank you.